So this is the big kahuna we've been waiting for. We've been factoring all of these different types of polynomials so that now we can actually solve them. So big fancy equations that you can actually solve because you know how to factor. So when we're factoring to solve equations like this, the first thing you want to do is look at the equation and decide how are you going to factor it. Is it a trinomial that you're going to factor? Is it a GCF that you're going to factor? How are you going to actually factor it? So step one, decide how to factor the polynomial. Is it a trinomial? Does it have a GCF? You have to decide. So we're looking for, does everything share something? That means it's got a GCF. Or is it one of our trinomials where it has 3 terms? And we're looking for factors of C that add to B. So that's the first thing we've got to decide. Once we decide what we're going to do to factor, then we actually want to factor it. So the next thing we're going to do is factor. And after we factor, we're going to take each factor, set them equal to 0, and solve them. So it's like we're going to get 2 equations to solve in one after we factor. 3. Set each factor equal to, I didn't give myself enough room. 0 and solve. So we're going to factor it, set each factor equal to 0, and then solve each factor separately. So we should be getting 2 answers for these problems. So they're going to look something like this. Like example number 1 says, solve x squared minus 7x equals 0. So the difference is we're taking that polynomial that we've been looking at and we've been factoring, and now they're going to set it equal to 0 for us and actually ask us to solve it. So we're back to the good old days of where we're going to actually get a number for our answer instead of just a big long string of variables and coefficients. All right, so if we're going to solve x squared minus 7x equals 0, the first thing we want to do is we want to look at that and say, is it a trinomial or does it have a GCF? How do I want to factor that? X squared and a 7x. Do they have anything in common? Yeah, they share an x, right? So because they have something in common, I want to factor that GCF out. I see that they both have an x, right? So that tells me I can take an x outside. When I take an x outside and I divide both of these by x, I had x squared, I took an x away, so I'm just left with x on the inside. I bring down my minus sign. 7x, take x away, just leaves me with a 7. It all still equals 0. I just bring that equals 0 along. And then I'm going to write 2 separate equations. So I'm going to take my first factor and set it equal to 0. And I'm going to take my second factor and set it equal to 0. So anything that's outside the parentheses is considered your first factor. So x is going to be my first factor. So that's going to be my first equation. X equals 0. And then the inside of my parentheses is my second factor. So x minus 7 equals 0 will be my second equation. And then I'm just solving both of those. Now the blue one, I really don't even have to do anything, right? X equals 0, the X is already by itself, it's already done for me. There's nothing else I can do there. So my first answer is just that X equals 0 because X is by itself, it's done. The purple one, the X minus 7 equals 0. I've got to move that 7 to the other side, right? When I do that, my 7's cancel, and I'm left with X equals 7. So my two answers for this would be 0 and 7. Alright, so let's try a little bit different one. Let's try and solve 9x squared minus 6x equals 0. 9x squared minus 6x. Do they share anything? They both can be divided by 3, definitely. 3 and an x, right? So I can take out a 3 and I can take out an x, which means I'm going to go back in and divide both of these things by 3x to see what's left over. When I do 9 divided by 3, I get 3, right? X squared, take away an x, gives me x. Bring down my minus sign. 6 divided by 3, 2. X divided by x is saying I had an x, I took an x away, I don't have any x's left, I took them all. And the whole thing still equals 0. So then this is my first factor, this is my second factor, so I want to set them both equal to 0. So I say, okay, 3x equals 0, and 3x minus 2 equals 0. And then I want to solve both of those. So 3x equals 0, how do I get rid of that 3? I divide it, right? I divide both sides by 3. 0 divided by 3 is still 0. So I'm still getting x equals 0 here. And then I've got 3x minus 2 equals 0. So first I've got to move that minus 2. So I'm going to add it to both sides. I get 3x equals 2. And then I've got to get rid of that 3. So I divide it. 3's cancel. And I'm left with x equals 2 divided by 3. Can I simplify that at all? No. It's a fraction, but it's okay. I can just leave it as a fraction for my final answer. So it is okay if you're getting fractions for answers here. Not too bad? All right, let's try some trinomials. Make sure we remember our factoring trinomials. So now the difference here is they're asking us to solve x squared minus 7x plus 6 equals 0. So right away, I see I have an x squared, I have an x, and then I don't have an x, right? I just have that plain old 6, that constant there. So I can't factor anything out. They don't have a GCF. But I do notice I have 3 terms, which means it's a trinomial. So now I'm asking myself, what multiplies to 6 and adds to negative 7? So I'm looking for factors of 6 that add to negative 7. So if I'm looking for my factors of 6, I've got 1 and 6 and 2 and 3. If I want them to multiply to be a positive number, that tells me they both have to have the same sign. Because positive numbers, both positive or both negative, would multiply to be a positive number. They have to have the same sign, but I want them to add to be a negative. So that tells me that both of my factors have to be negative. So then I'm literally going to say, okay, -1 minus 6 gives me -7. -2 minus 3 gives me -5. I wanted to add to -7. So the factors that I'm going to choose are the ones that multiply to 6, 1 and 6, and add to -7. I don't want to choose 2 and 3 because that adds to be -5. Not what I wanted. So once I do that, then I say, okay, I have x minus 1 and x minus 6 all equals 0. And then I can take my first factor and set it equal to 0, and my second factor and set it equal to 0, and then solve both of them. So I'm going to end up with x minus 1 equals 0, and x minus 6 equals 0. I'm going to add 1 to both sides and get x equals 1. The other one, I'm going to add 6 to both sides and get x equals 6. Now, at this point in your solving equations career, if you can look at x minus 1 equals 0 and you can solve that in your head, if you know you just have to add that 1 to the other side in your mind, I'm okay with you not physically writing the +1 on either side and drawing a line and crossing it all out and showing me that whole step, because these are things that as you move on in your math career, they're going to keep showing up and they're going to be at the end of the problem. So your teacher is going to be looking for you to be able to recognize these a little bit faster. So if you're starting to be comfortable not showing that +1 or that +6 on both sides, it's okay for you to just tell me that that equation equals 1 or that equation equals 6. Does that make sense? If that's starting to, like, you look at that and you recognize it right away, you don't have to waste your time going through and writing it. If you like writing it because it keeps you organized, by all means, absolutely go for it. But I don't want to hold you back if you're like, I already know the answer. All right, last one. The 2x squared minus 9x minus 5 equals 0. So now I see 2, a 9, and a 5. They don't have a GCF. I see an x squared, an x, and then no x. That's not a GCF. But I do see that I have 3 terms. So this is going to be that bottoms-up method of factoring, where the first thing we're going to have to say to ourselves is, okay, 2 times -5 gives us -10. So now we want factors of -10 that add to this -9. So we want things that multiply to -10 and add to -9. First, I'll find my factors of 10. So I've got 1 and 10 and 2 and 5. Since I need it to be a -10, I know one of them has to be negative. And since I want it to add to be a negative number, that tells me the bigger number has to be negative. So in my factors, I've got to have a -10 and I've got to have a -5 because those are my bigger numbers. They have to be negative. So then I literally do 1 minus 10 and I get -9. If I wanted to check myself, I could do 2 minus 5 just to make sure. 2 minus 5 gives me -3. So I definitely want to use 1 and -10. So then I go in, right, and I write my 2 sets of factors. I say x and x minus +1 and -10. This whole thing still equals 0, so I'll bring that along just so I don't forget. Am I done factoring this? No, right? I've got to undo that multiply by 2 that I originally did. So I've got to go back in and take this 2 and divide both of these. Because I can't simplify a 1/2, I can just bring the 2 up. I can bring that bottom up. Here, I can simplify 10 over 2 to be 5. So now I'm going to have 2x plus 1 and x minus 5 equals 0. So now that I've factored it, from here, I can take my first set of parentheses and write my first equation. I can take my second set of parentheses and write my second equation. So I'm going to get 2x plus 1 equals 0. X minus 5 equals 0. First one, I'm going to subtract 1, right, on both sides. I get 2x equals negative 1. And then I divide by 2. And I get x equals negative 1/2. The other one, x minus 5 equals 0. I've got to add that 5 on both sides. So you could just tell me x equals 5. Or if you like to still write it, go in, we cancel out our 5s, and we get x equals 5. If you wanted to check your answers, if you weren't totally sure, or if you came out and at the end you were like, whoa, these are kind of weird numbers, you could always take, like, your x equals 5. You could take that 5 and plug it back into the original equation and see if the whole thing ended up simplifying to be 0. So you could always take your answers and plug them back in and see if it makes the equation simplify to be 0 to check yourself.